Okay, we're on the test bench today, or the workbench, my repair center for all things arcade electronics here. And what I've got on the bench today is a pair of Joust boards. And neither of these are working, so what I'm going to plan to do with one of these is get it working from the parts of the other. Just to at least get a second board working for Joust. What's interesting is between these two boards, even though they're the exact same revision and model number, you can see the parts that are on the board are just slightly different. You can see here as opposed to here. You can also see the mask that's on the board itself. On this board's a little bit thicker, and over here it's very thin, not as pronounced. Going through all the components here. So what I'm going to be doing first is just looking over each board to look for any visual problems that are easy to see. See which board is probably going to be the easiest to work with. Right off the bat, I think this one over here, I've gotten it to boot, at least to a point where it's got something on the screen, and this one over here's got other issues. Even though this is the nicer looking board, I think we've got problems somewhere either on a reset circuit or with the CPU itself. This one actually seems to boot and produce video. So anyways, let's start looking at the board and see what we come up with. So even though I think this is a nicer looking board, I want to put the other one into the into the pen device here. Well, I say that the other one was a nicer looking board. I think this is a better board overall for a couple of reasons. The PCB itself was, or appears to have been manufactured by a different manufacturer than the other board, and all the traces on the board are really nice. The way that they screened the board out and laid it out and printed it, I think it's higher quality. So, and it's based on like the grounding plane that goes around the edge of the board here is a lot nicer than the other board. The other board is kind of like just a mound of solder that goes all the way around. It's very ripply and rough. It's thick. It's nice, but this is just seems a lot nicer, especially right up in this section here. This is a really nice laid out section. So overall, I think the quality of this board, I don't know in particulars, but it just looks like the quality is better on this board. So I'm gonna stick with this board, get this guy working, just do some common cleanup on him, and look for bad components that I might want to replace, swap things around a bit, and to get this board up and running. So definitely I'll surely go after all the headers up here, reflow solder on these areas, pull all the chips off of the board, and clean those, clean the sockets. If need be, I'll probably replace sockets if I need to. I'll have some in an order, so we'll get to that when we need to. But for right now, I think a good cleaning and removal of all the socketed chips is a good place to start. Right, so the first thing I'm going to do is remove some of these RAM chips. Well, you've got a couple of different options for chip removal. A lot of people just go with the standard screwdriver, and that's okay. I've got a longer handled Craftsman here. A good option. There's a smaller one. Just a shorter shaft on this particular driver. And then you have something like this, which is a special or specific tool for chip removal, and this isn't very much. I would definitely recommend picking up something like this. This is from Weha, which is I think that's how you say their name. Really good manufacturer of tools, and this is a great one to have. It's got a special curvature to it, and it makes especially getting into tighter spaces for lifting chips a lot easier, and also keeps you from bending pins as easily, so it works its way into between the chip and the socket quite easily. So you can get in there to get the chip lifted up and get it out of its socket without potentially damaging anything. So there you go, there's the chip. Comes out just like that, and see all the pins are still perfectly straight. No problems there. So I'm going to go through the board and remove all these chips and probably get the legs cleaned up and have the sockets exposed so I can get the sockets cleaned as well. So I'm going to do a little bit closer of a shot in here of removing the chips. So I'm going to take my tool and come in on one side, and you feel it get underneath the chip. And you can rock it straight back, or you can kind of rock it side to side to get a little bit of lifting. Now once you've lifted it up a little bit on one side, you need to come back to the other side. If you can't get it under, just push it. You'll just push it down just a hair to get your tool in there, so you can get it lifted up on that side as well. And just work it a little bit at a time on each side. No need to rush it, because if you rush it one way or the other, you're going to end up with bent pins, and they'll come out quite easily. Just take your time, no rush, to get each one of these chips out. So there you go. So I've emptied the first bank of chips. These are all RAM chips. They are 4116 RAM chips on the Joust board. Now there is a modification you can do to this board to replace all the RAM chips on the board with a different kind of RAM chip, which doesn't require the plus 12 voltage, so they run more efficiently and cooler, so they should last longer. I'm not doing that mod on the board today. I don't have all the RAM chips necessary, and since I have extra 4116s on spare boards, I may as well use them. Now at some point I'll probably do the modification to an existing board that's down. I'll go ahead and do all the RAM chip replacements on that, modify the board for the power, and see if I can get it running that way. But for today, I'm going to be maintaining these 4116 RAM chips. Okay, just the last two here. Get these guys out, and then I'll probably move on to the decoder chips. So for a piece of cake, no problems. Okay, all the DRAM sockets now exposed, and I should be able to get them cleaned up. I don't know if you can see this or not, but you can see some of the chips that I pulled out from the board have quite a bit of buildup on the legs themselves, which I'm sure will inhibit any sort of electrical connections. So the bottom chip, you can see there, is quite a bit shinier than the top one. That's because I've gone through it with a wire brush. The next thing I would do with the chip is clean the legs thoroughly with contact cleaner, or at minimum alcohol, to make sure they're nice and clean. So instead of just a manual wire brush, I just grab the Dremel here and set it to put the wire end on it. Set it to a low setting here, nothing too quickly. Wear your safety glasses, of course, and just lightly go over the legs of these chips to get them cleaned up. Put over. that's pretty much it. It doesn't take much. Just a little bit of time, but getting all that buildup off the metal itself is going to expose good clean metal for good electrical contact. And there goes the chip. Stay with me, guys. So the next issue on this board, I think I've got the issue with the same one I have working right now, is these header pins. One, they get really dirty. Two, I think there could be a potential issue for cold solder joints on these, because there's a lot of stress that's applied to these particular headers. Also these as well. So these two, as well as this one over here. Plugging in and unplugging the power connector to this board seems to put a bit of undue stress. So currently the board that I have working in the Joust at the moment kind of tends to work and not work based on how you have the connector connected to the board, basically. I mean, if it's, you just kind of jiggle a little bit, reboot the game, and it seems to come up just fine. So I'll go ahead and take the Dremel and clean these up here as well, and then after I do that, I think I'll go ahead and hit it with the I'll desolder each of these header pins and then resolder them to do a proper reflow. So let me go and get these cleaned up, and then we'll go ahead and get them resoldered on the board. Alright, now that they're all got most of the junk off the pins, I'm just going to take a little square here and some deoxit. Spread a little deoxit on my little square, and then I'll just wipe the pins off. I'm just getting the paper towel in here and just cleaning both sides of the pins to make sure they're nice and clean. And the deoxit will help remove any other leftover bits of bad nasties that we don't want on there to keep us from getting a good electrical contact. So we want to get these things working well. It's hard to get on the back side of these pins. I figure if I get 3 sides of the pin, we should be good. They look a lot better than they did before. They were very dull. Look, they had some sort of oxidation or some sort of corrosion on them. It didn't look like the alkaline damage from the batteries, but they still looked shoddy. So hitting them with a wire brush and then getting some deoxit on there, I think is really making things look a lot better. So I think this will do just fine. Yeah, definitely looks a lot better. nice and shiny. Okay, so I'm going to go ahead and resolder these, and I think that'll be the next step. So let's go ahead and get the soldering iron warmed up and get to reflowing some solder. Okay, so as usual with most of this, I like to... Tip seems a bit dirty. I must have walked away without getting that clean like I usually have it. So I'm just going to clean my tip up here a little bit. Okay. So I'm going to come back here. I've turned the board upside down so I can work a little lower. So I'm going to come in here and try to freshen up. So the first thing I'm going to do is try to first just add some... I want to actually desolder these, I think. That's what I plan on doing anyways. Is desolder, pull all the old solder out, and then just completely add new solder to these joints. Okay, so just like that. Okay. Grab a new strand here. This section right here. These two are bridged, which they should be. I'm just making a mental note that they are. This guy's not heating up like I expect him to. There we go. Just had to flux him up a bit there. He was being quite stubborn. So these boards with alkaline damage are very difficult to do much with. To solder, to desolder. It's just a... Oop, I just bridged those two big time. It's just very difficult to work with them. And it takes a lot more time and a lot more heat to accomplish much of anything. So here I'm applying heat to this pin, and I'm only getting solder melt on the bottom half of the pin. I'm not achieving full solder melt on top and bottom here, so it's a pain. Alright, so I've hit them all with a little bit of solder, so they should be good to desolder. I'll grab my desoldering gun here and see if I can desolder one without dropping a pin. The pins are hot, so. Yep, okay, so that pin's still good, still in there, no problem. And I'm not trying to remove these pins, so I'm not really moving my gun around, I'm just pulling most of the solder out. Very good. Okay, so let me start with those. Just clean it up. I don't want to add any, I don't want to push on these pins or anything, I just want to. Well, now I got some stuff on there that I don't want. I got little fuzzies on there. Let's see if I can brush them off real quick. There we go. Okay. So let's get some fresh solder on these pins that I've desoldered. Now I'm hoping this will go on a little easier. Shouldn't be so difficult. Shouldn't make such a giant mess. There we go. Yeah, it's not adhering. Yeah, may have to add some serious flux. So let me do that. Get some flux on there and we'll hit it again. Alright, so let's add some flux. Just a little bit. Not much. Let's see if that'll help a little. My brush has gone stiff. Let me clean it off. Alcohol. Brush in here. See if that'll soften the bristles a little bit. Break them up. There we go. Much better. Okay, let's try that. Boy, this is difficult. I feel like I'm just not getting enough heat. Mm. Well, that worked okay. There we go, a better angle there. It's helping. First one is ugly. I want to come back and hit that one again. That's much better. I'm having to lay a lot more of the iron onto the pad to get enough contact. That one was much better. Woo! Toasty! And now I need some more solder. 1 second. Clean these up, so I'm not happy with it. Wow, I'm just not getting a heat transfer at all. There's probably still some contaminants on here. It's really giving me a problem. Looks a little better. I'm guessing it's just the trace. There's such a large trace. Okay. So I'm going to get these next two guys. Nice and clean. It's pretty good. Much easier. Goodness gracious. Okay. Those are nice. Actually, there's okay. There's actually no pin there, so that's why that looks a little odd. That's better. Okay, let's come around here. Well, they definitely look much shinier than they were before. That's for sure. These are going much nicer. I'm going to go back and do those first ones again because I'm just not happy with them. Okay, those look good. Looking good. Okay, let me go clean up those. Alright, so next I'm going to take out these decoder ROMs, just for the sake of being thorough. They look pretty good. I'm just going to go ahead and take these guys out, get them cleaned up as well. Alright, so there he is, a little dirty on the bottom, but the legs look pretty good. So I'll give him a quick cleaning, and I'll clean the socket, and then I'll put him back in place so I don't get these mixed up. Since these legs are in really good shape, there's not a lot of buildup on them or corrosion or anything like that, I'm just going to use my brush here, a soft brush, to, if there is anything on there, go ahead and remove it. But I'm not going to take a wire brush to this. There's no real reason to. So it's in really good shape, so I'll keep it this way. No reason to mar up good legs. Go ahead and take a toothbrush with a little bit of high percentage alcohol on it and just brush off the socket here, get inside of it, just kind of clean it up a little bit, try to get the bristles inside the holes. I could replace the socket, but larger ones get quite expensive and I don't have any, so I've got to order those from Mauser. So I'm just going to brush it out. If there's anything in there, loosen it up. And just give a quick spray. Hit with a blast of cleaner real quick. And spray it again. That should be a good socket. For the chip, again, some deoxit cleaner, a little bit of rag, just spray on the rag, and I'll just wipe the legs of the chip. And that gets it nice and shiny. Okay, the chip is all nice and clean now. Went ahead and hit it with the, this thing could focus. That would be great. Still don't feel like that's in focus. There we go. So it's been cleaned with the deoxit to remove any sort of oxidation or contaminants on the legs. So it's good and clean now. I'll go ahead and put it back in place on the board, making sure I get the orientation right with the notch and the chip, following the rest of the board. And get these guys in, just align the legs into the socket. And I like to squeeze both ends on these larger chips, get them all nice and centered, And then once they're nice and centered, they're easy to press down and get into place. That's it. It's in there. So let's move on to the other socket, and I'll get it cleaned up as well. So this next decoder ROM, start lifting them out. Nice and easy. So if one side starts to pop up, just put a little pressure on it to keep it in. And lift the other side. I like to use a little bit of a twisting motion to lift it. There we go. And out she comes. There we go. Nice. Alright, let me go ahead and get this guy cleaned up and get the socket cleaned up, and then we'll put him back in place. Okay, he's nice and clean, all nice and shiny, ready to go back into the socket. Lined up. Alright, he's lined up, ready to be pushed in. And there we go. Nice and secure, clean chip, clean socket. Alright. Let's move on to this guy. He's quite a bit larger. This may be an instance where going for a screwdriver might not be a bad idea. This has been in here for a long time, so it'll sound a little weird as you pull it. You'll hear a little bit of creaking and as the pins are being removed from their stagnant location. So I'm just kind of slowly working my tool in and lifting the chip, just bit by bit. I'm actually doing a kind of a rocking down and a rocking back, so I'm kind of doing two different lifting motions here as I'm working in the tool. You can hear it slowly coming out of the socket. I'm in no rush, taking my time. It's definitely lifted this one side a little higher than the other, so I need to be careful and hold it in position as I break the other side free. There we go. It's certainly loose now. I should be able to just lift it straight out. There we go. This one's a little dirtier, but overall still pretty good. So let me just go ahead and clean the chip up, clean out the socket, and we'll put it back in place. Okay, all the chips are mounted on the board here, so I'm thinking I'm going to pull this thing out of the vise and plug it in the game and see what happens. Alright, so first round, I don't think I've got it. Looks like I've got a, well, it's a general RAM error. It's giving 131. And I think 3.1 is actually this first RAM chip in the bank. So typically that means you can't read any RAM, so it's like a general RAM failure. So it may not just be one particular chip or something, but this is the output you get on the screen. If you can see, it's kind of just a gobbledygook of colors, and it'll scroll through stuff as it tries to boot. So this is what you get. And it'll just do this over and over again. So I mean, it's not totally dead, it just gotta fiddle with it for a bit more. I'll probably maybe swap out all the RAM chips, but I'm thinking it's just the communications down to the RAM itself is goofed up on the board. So I gotta trace where I'm not getting signaling across, where the bits are not flowing properly. So let me I'll do some poking around here and see if I can't find where the problem might be. So stick with me, guys. We'll get this one figured out. No problem. Alright, I just finished up another board repair. I didn't record this one. I'm trying to move quickly on a few repairs to get things moving along here, but this is another Joust I've been working on. Just another Joust board, actually. And you can see it's booted up here, and here's the board set I was working on. This one in particular had an issue with a TTL chip, and it's one of the muxers right here, and he drives a lot of the data bus that goes to the RAM chips down here. And one of the common problems with these Williams boards is you'll get a general error off the ROM board, which is this game's kind of neat. The Williams setup is that they have an error display here, a little LED, and a lot of times you'll get this 131 error, and it's a difficult error because basically what the 131 indicates is it indicates the error code itself. One means it's a RAM error, and the next two values mean that what RAM bank and then what RAM number. So if you look in the manual here, you'll see that there's a when you're reading off the ROM board off the LED, that the first number 1 means it's a RAM error, and then the following numbers is the bank number and then the chip number. So, and then they give you this handy little reference down here in the middle, the manual, which gives you the bank up top here. So it starts with bank 3, bank 2, then bank 1, and then all the RAM chips here. And 131 would be RAM error bank 3 first chip. Well, essentially that means that the RAM number 1 fails the test. So either this RAM is bad or it can't read or write properly to any of the RAM chips, essentially. So that's why you'll have a lot of different issues on these Williams boards, and you'll see a lot of references to the 131 error. For this one in particular, I just used my logic probe and the schematics, and I just looked for anything that was out of whack on the board. When I was diagnosing this 131 error, I didn't use anything else. And I had found that this one was kind of weird because I troubleshot this board once, and I found that this chip right here, the output leg, which is pin 7 on this TTL chip, was dead. I mean, it was like as if it were floating, so like inside the chip, as if it were disconnected, and there wasn't any signals being sent to the leg and then down into the circuit to go towards the RAM. So at that point, I just chalked this one up to be a problem. Ordered the part, which is a 74153N, and ordered that in and waited for it to arrive. And it took a little while for me to get back to this board set, and I plugged everything back in, started troubleshooting this one again, make sure that I was troubleshooting the correct board, and I was checking this chip, and I was actually getting signals off that leg, which really confused me. I was like, I thought this was bad, right? What I was doing was I was trying to find. I couldn't remember which one of these if it was this one, or this one, and I could not remember, for the life of me remember. So I was checking all the legs and all these chips, and they all had some sort of a signal, which was very confusing to me. So I was like, well, I'll come back to this later. Well, came back to it again today, and I actually had a couple other issues. The first of which was that the CPU here was having some troubles reading the ROMs, and I was getting like a 333 error and a 253 error, and it was really strange. At first I'd start it and nothing would happen, and then I'd push on the CPU chip, and then I'd get some error readings over here. I was like, well, that's interesting. So I just went ahead and popped the CPU out and cleaned and deoxed all the legs on the chip, and then put it back in place. And then without fail on every single power up or boot, it would just flash through the 131 error, which would that got me back to where I was before. All fine and dandy. So I went back to troubleshooting these guys here again, and I found, okay, this guy was acting kind of flaky, and the condition is that the pin 7 here, when the board was, or when the chip was cold, it would actually have signals flowing across the leg, but they were high, and while it ran, the voltage levels on that pin 7 were slowly dropping. They started around maybe 4 volts, and they started working their way down as the board was on and powered with as 5 volts was going to the chip. And I watched this the input voltage to the chip, and it was a steady 5 volts, no problem. But off of pin 7, it was continually dropping as I held my logic probe against it. The logic probe has the LEDs on it for the high-low here, but it also has a little speaker down here which makes sound, which is kind of neat because it gives you an audible tone to kind of indicate how high the voltage is. So the higher pitch, the higher the voltage; the lower pitch, the lower the voltage. And you could hear it just kind of start draining and winding down as the voltage was dropping. So it sounded really pathetic until at which point that pin 7 had nothing. It would actually just drop to no voltage, no readable voltage from the logic probe, which then appeared to be dead at that point. So I went ahead and removed the existing 74 153N, and that's what the original looked like. It was one of those guys. And let me go ahead and run over to the schematic here. We'll take a look at it, where it actually exists on the board. If you look at these board sets, this is another Joust board that does not work, that I'll probably hopefully get to working here later. But you have the let's see here. So you have letters down the side here, like A, B, C, D, E, F, and then just numerals on the bottom down here. So 1, 2, 3, 4, 5, 6, 7, and that's how you locate like the location of a chip. It's the coordinates on the board, and we're looking at 3D right here. This guy is 3D. So let's run over here to the schematic. Whoop! Kill myself. And here's the chip, 3D. And what's going on here is pin 7, as you can see, is actually part of the memory address bus. And that's why that if he's bad, or if he's bad, or if he's bad, so any of these 74 153 chips, if they're not outputting signals correctly to the memory address bus, you're going to get a 131 type error, because this address bus is going to all of the RAM chips, as you see here. It's feeding all of these 4416, 4116 RAM chips. So if you're getting a 131 error and you know your first RAM chip is likely to be good, obviously the common things you want to do is check the voltages. If you're running the 4116s, you got to check the voltages on all 3 legs. Make sure you're getting +5, -5, and +12 to the chip. And if that is all good, I would check each leg to make sure that the signals going to each one of the legs is correct. Make sure that the data inputs are correct. Make sure it's got the addressing signal to all the chips or is working and toggling properly, because it's got these CAS signals. The write enable, make sure that's toggling properly. The RAS signal, and these are like I think they're some type of synchronization. I'm not really sure, as far as it's just like a to keep everything in sync as far as what's being written to, what's not being written to, those sorts of things. So those should be beeping away normally, and those are the things you kind of want to look for. For me in particular, the pin 7 off of this guy was just trashed when you first boot. Then you'd slowly die off and then just send nothing at all. So he was bad. So once I replaced him, I flipped the board back on and immediately got a new error. And the error I got was a 115. And so that led me to start replacing RAM chips off of the bank here. And I ended up taking and replacing, let's see here, 4 chips. So I booted, replaced, booted, got a new error, replaced another RAM chip, booted again, got a new error, replaced another RAM chip, and then finally the last one I booted it, replaced it, and then booted one more time, and the game came to life. Here's the guy I actually pulled off the board. I'm getting pretty good at pulling these TTLs off the board. I did not cut the legs off of this chip. I actually used my desoldering gun and sonic vacuum, and a new method here I'm trying with flux and heating on the top side and pulling, and it worked extraordinarily well. It came out like butter. It was great. So I'll keep working on that, which will maybe save me, I don't know, cutting sometimes works, cutting sometimes doesn't work if you can't get your flush cutters where they need to be, cutting bad chips I would recommend. This guy is definitely bad, so cutting him out would have not been a problem at all. I also think it probably wouldn't have been too bad to get some flush cutters in there. There's not a whole lot around the chips, so I probably could have got some flush cutters in there, no problem. But I just wanted to go ahead and take another shot at seeing if I can properly desolder a dual inline pin off of the PCB, and I did a pretty good job. So it came off nice and cleanly. All the pads are perfectly still intact, so no problems there. So anyways, yeah, the game appears to be working pretty good on a spin around here, and so it doesn't have any sort of battery backup or anything like that, so it doesn't keep any of the bookkeeping. So here you just have to advance the screen past this, and then there you go. And I notice it takes a little while for whatever reason before it accepts credits. I'm not sure if I have to advance through all of the. See, it gets here. Oh, here it goes rebooting. And it should come back here in a second. There we go. That's what you want to see when you first boot up. Awesome. Happy day. Go ahead and hit advance one more time. And I'm just hitting the advance button down here, which is the third button here. And we're back to the score table. And it should take credits at this point. There we go. And it's alive and well. And it's running off of the original 4116 RAM chips. I highly recommend doing the mod to put on the different types of RAM chips. Got a couple of different options you can use, and I'll post those in the bottom of the video so you guys can look at some of the options you have for getting rid of the 4116s and replacing them with something a little bit more reliable. They tend to overheat and go bad because they're pulling all those different voltages. There you go, it's working. You do? Yeah. All right, well, let's play the game, okay?